So this video is really about tying like everything from this whole chapter together. All right, I mean, the title here is finding absolute extrema from a derivative graph. And I've already got steps lined out. And sort of the reason that we're pulling all this stuff together is, so first, we know how to find absolute extrema. We find them by basically looking for all the critical numbers and then plugging those critical numbers into my original function and the end. Remember, the endpoints of the interval also. Whatever the largest value is, that's your absolute maximum. Whatever your smallest value is, that's your absolute minimum. Right? The place where I'm making this different is, what if I didn't have the original function? What if I had a derivative graph for this thing? So my steps should make sense. Step 1, find all those potential mins and maxes, right? Look for where the derivative is 0 or undefined. Look for endpoints of the interval. Then, normally we would plug all those things in. In this case, we're going to have to find the value of the original function by using the integration methods from basically yesterday, right? The fundamental theorem of calculus, basically using that to evaluate the original function. And then just looking at them and saying, hey, look, the largest value is the absolute maximum, the smallest value is the absolute minimum. I've got one graphical example of this, so we'll look at that right now. So I'm about to make a mistake in the example I'm about to do, but I don't have time to go back and re-record the video, so I'm inserting some audio here. The problem is about to say between times 0 and 12, and it's supposed to be between 0 and 9. I realized that error about 4 minutes into the problem, but just heads up, as you're reading the problem, it's going to say between 0 and 12. Anywhere you see a 12, it was supposed to be a 9. Sorry, here comes the example. So an object moves along the y-axis between times 0 and 12 with the velocity given in the graph below. So it's like giant flashing warning, like, hey everybody, by the way, this is a velocity function. Hey, by the way, that's the derivative of position. Incredibly common question. Right? They want us to determine the highest and lowest points the object reaches on the interval if its height at time 3 is 10. So my step 1 is supposed to be, what are my potential mins and maxes? What are my critical numbers? Right? Well, there are the endpoints, which are 0 and 12. And then there's where the derivative, there's where velocity is 0. And that happens in one place. That happens when time is 7, right here. Okay? So step 2 is basically where I say, okay, what is y of 0, what is y of 12, and what is y of 7? Like, what is the position at all 3 of these values? If I had a position function, I would just plug them in. Because I don't have a position function, what I'm going to have to do is I'm going to have to find out what those things are using my fundamental theorem of calculus. Right? Note that the one piece of information that they gave me was that the height at time 3 is 10. In other words, they told me that y of 3 was equal to 10. Right, so I'll walk through the first one of these for you. If I want to know what y of 0 is, I'll start with y of 3 and add on to that the integral between 3 and 0 of the velocity function. I think it's definitely worthwhile for you to pause the video now and make sure that you can do that. So take a second, pause it, and do that. Alright, so this one is going to need, the integral from 0 to 3. 0 to 3 is that region there. And I suppose I would see this probably as a triangle with a rectangle on top of it. This thing up here has an area of 3. This thing here is 3 by 3, which makes it 4.5. So the total area of that section there is 7.5. Right? Now note, the integral from 0 to 3 of v of t is actually negative 7.5, because all of that area is below the x-axis. However, this integral is asking for the integral from 3 back to 0. So that's going to change the sign back around, right? Y of 0 is y of 3 plus positive 7.5. And I just realized that y of 3, we were told that y of 3 was 10. Right? So this gives me that y of 0 is 17.5. So we figured out our first value here. Right? I now need to go through the same process to get y of 7 and to get y of 12. Again, I'd really recommend you guys pause the video and do these one at a time. I'm going to go a little bit out of order and do y of 7 next. Right? So y of 7 should be y of 3, because that's the one they gave me, plus the integral from 3 to 7 of v of t dt. Okay? So y of 7 is 10, which they initially gave me, plus the integral from 3 to 7. So let's see here, the integral from 3 to 7. We're looking at a rectangle here and a triangle here. The rectangle has an area of 8. The triangle is 4 by 2, so it has an area of 4. So I'm looking at that integral. It's going from 3 to 7. That's the proper direction, so I use the orientation from up here. This is going to be negative 12. I just found that y of 7 is negative 2. So I can sort of compile that in my list of values up here. Negative 2 for that one. Last one I need to do is y of 12. And this is going to take a little bit of jumping around, but we'll get through it here. The integral for y of 12. Y of 12 will be, and it's interesting, if you guys paused it and did it on your own, I wouldn't be surprised if you did this. Y of 3 plus the integral from 3 to 12 of v of t dt. Your other option, though, is to say, I just found out what y of 7 was. I could say that y of 12 was y of 7 plus the integral from 7 to 12 of v of t. Either one of them will work. I'm going to go ahead and go with this one because it sort of leverages the work that we already did. So moving along, we have y of 12 is y of 7. We found that was negative 2 from up above, plus the integral from 7 to 12. 7 to 12. I don't know why I've been using 12 for this entire problem. The endpoint all along was supposed to be 9, and that's really frustrating. I imagine you guys all caught that. I apologize. So now I just need the integral between 7 and 12. I've got a triangle here that has area 2, and a rectangle, that has area 1. I'm just full of mistakes right now. Area 1, and a rectangle here that has an area of 2. So, coming down here, again, correcting my errors, this should be a 9, 9, 9. Wish I had time to actually go back and correct all those properly. This integral we just found out up above was 3, so y of 9, not 12, geez, y of 9 is 1. So I can bring that back to this list of information that I had here. This is 1. These were all of my critical numbers, 0, 9, and 7. Those were all of my critical numbers. Those were all the possible maxes and mins. Now that I've evaluated the function, I can tell that my maximum was 17.5. It happened at time 0. And I can tell that my minimum was negative 2, and it happened at time 7. So I hope you can forgive me for that big mix-up with me saying that 12 was the other endpoint. 9 was totally supposed to have been the endpoint. Yeah, sorry for that slip. Did I say that in the original problem? Yeah, I even said between times 0 and 12. What a mess. Oh well, should have been 9. I'll go ahead and change it here. Yeah, I hope that made sense through all those errors.